Oh, on the warm-up, we're just going to solve, right? So I've got subtract 5 and then subtract 1. I'm just going to kind of do them both at the same time. And I've got negative 3a is less than or equal to 3, or 2a is greater than 6. So divide by negative 3, divide by 2, and I've got a is greater than or equal to negative 1, or a is greater than 3. Okay, so if I was to graph that, I'm just going to do a quick sketch, not a real graph. So, and I have 3. So it'd be solid on 1 and open on 3. And it's greater than 1 and greater than 3. So interval notation would be from negative 1 to 3, because 3 is not included. So I can't say negative 1 to infinity because 3 is not included in there. So if I just said negative 1 to infinity, 3, that would mean 3 was included. And 3 is not included in not included, so I have to write it separately. I should have put a union sign between them, but it's okay. Sorry, I just got a message from someone in class. Okay, so on number 2, I have to get rid of the fraction first, so I'm going to multiply by negative 5 everywhere, right? Oh, negative 5. So the 5s go away there, and I get 6, and I multiplied by a negative number, so my sign switched directions, is greater than or equal to x plus 2, which is greater than or equal to negative 30. So subtract 2 from everywhere, and I get oh, that's negative 5. I don't know why I had negative 3. So sorry. I was like, that's not right. That should be 10. Okay. So a is greater than or equal to x, which is greater than or equal to negative 32. And another quick sketch, I have negative 32 and 8, and they're both solids. And it's greater than 32 and less than 8, so it's in between there. So it would go from negative 32 to 8. Boom. Okay. All right. So there's our warm up. We're going to go ahead and start. We're going to talk about absolute value today. By the way, before we start, you guys do have the checkpoint. It's due on the checkpoint for 2-1 and 2-2 is due on Friday. So it is available. You can work on it on Wednesday if you want, or you can work on it now. It's not due until Friday, so I just wanted to put that out there. Okay, so the first thing we're going to do is define some words. That's okay, Harrison, not a problem. So we're going to define some words first, and then we're going to go on. Oh my gosh, I almost forgot what I was talking about. So we're going to define absolute value first. Absolute value is the distance from 0, a number is on the number line. Okay? And when we talk about distance is never negative. And one of the easiest ways you guys can tell, I think most of you guys drive now, I think, or thinking about driving, whatever. So if you drive backwards in your car, does your odometer, which is the thing that measures how far you've driven, right? Does it go backwards? Well, it doesn't, because distance is never negative. It always is positive. No matter if I'm going forward or backward, distance is always positive. So if I am on a number line and I've got 0, 1, 2, 3, 4, 5, negative 5, and I want to know what the absolute value, say I have the absolute value of x equals 4. So what it's asking, basically what this is asking, is how many numbers have a distance of 4 from 0 on the number line. Well, how many have a distance of 4? Well, I've got 1, which is 4, and then I've got -4, because -4 also has a distance of 4 from 0 on the number line. So x in this case would be 4 or -4. So absolute value, because it has two possible answers, a positive answer, has, for inside the absolute value, there's two possible answers. There would be 4 in here, so the absolute value of 4 is -4, and the absolute value of -4 is 4. So there's two possible answers that we can solve for x, and that's what we have to remember, because we have to do two separate equations when we're dealing with absolute value. One for this side of 0 and one for this side of 0. Okay, so we have a couple principles. So the first ones are for equals, if it's an equal sign instead of an inequality sign. And it says, for any positive number p in algebraic expression x, and please let me know if you need me to slow down and give you time to write. So the first one, which is what we just kind of got done talking about, the solutions of the absolute value of p, absolute value of x equals p, are those that satisfy x equals -p or x equals p. And we just talked about that with my example on the number line. Okay? And the equation of x equals 0 is equivalent to the equation x equals 0, because there's only one number that has a distance of 0 from 0 on the number line, and that is 0. So that means that whatever's on the inside of my absolute value has to equal 0. Okay? And then the equation, the absolute value of x equals -p, has no solution, because this, when we're doing this, we have to remember out here, this is my distance traveled. So this is my distance traveled and my distance traveled. So, and we already talked about distance, absolute value having, distance having not having a negative value, because, I mean, the most obvious example is the one I've already used, is when I'm driving backwards, my odometer, which measures distance, does not go backwards. So there's no negative distance. It's always positive. So if I have the absolute value of something equals a negative, it has no solution. That is not always necessarily true when it's an inequality, though. This is an equal sign. I want to throw that out at you. It's not necessarily true if it's an inequality, unless it's less than that negative sign, and it will always be negative, then it doesn't work. So, okay. Do you still need a second or two to write the rest of this down? Thumbs up. Everyone ready to go on? Okay. So I'm going to go ahead and move to the next slide. And then we're going to talk about the principles for solving for absolute value. And this is where it kind of gets tricky. And we're going to get to the examples. We'll get to the examples for this in a minute. It says, for any positive number p and any expression x, the solutions of the absolute value of p, x equals p, are those that satisfy x equals -p or x equals p. That was the equal one. The solutions of absolute value of x is less than p are those that satisfy -p is less than x is less than p. And this is where we kind of have to start remembering is this. So if this is my problem, this is what I'm going to set up to solve. Okay? And then the other one says if the absolute value of x is greater than p, so now we've switched the signs of my direction. And by the way, this is greater than or equal to. So it could be either one, okay? It can be the or equal to also. are those that satisfy x is less than negative p or p is less than x. So I have to remember this so I can solve it. Okay. And pause just for a second so you guys can finish writing this down. Please remember, once we go on to these next problems, if you're not putting answers in the chat box, you're not getting credit for today, for being in class. So I have started that because people are not participating or they're logging in and going and doing something else. So if you're not participating in class, you will not get those 100 points that go along with that, answering in the chat box. Okay, so here we go. So we're just going to solve these. That's it, just solve. Okay, so with absolute value, I just want to make sure the absolute value and everything that's inside the absolute value is by itself first. So if there's anything added or multiplied, I have to take care of that first. In this first equation, it's fine. There's nothing. It's just the absolute value of x equals 5. Well, how many numbers? So the question I'm going to ask myself is how many numbers have a distance of 5 on the number line? Well, I know that it would be 5 has a distance of 5 and negative 5 has a distance of 5. And there's really no solving on this one. That's the whole answer. It's just 5 and negative 5. So they both have a distance of 5 from 0 on my number line. Not too bad. The second one, I actually have to do some more solving. It says how many numbers have a distance of 7 from 0 on the number line? Well, I know that 7 has a distance of 7 and negative 7 has a distance of 7. So I'm going to take the inside, the 5x plus 2. That can equal 7 because that has a distance of 7. 7 has a distance of 7 from 0 on the number line. Or it can also equal negative 7 because negative 7 has a distance of 7 from 0 on the number line. So I have two equations to solve. X is not going to be the same on these two problems as they were like on number 1 where they were the same number. This one should have different numbers. Let me say that. It should. We'll find out. So subtract 2. So I've got 5x equals 5 and 5x equals negative 9. Divide by 5. And x is going to equal 1 or negative 9/5. Okay, so that's not the same number. The only time it'll be like the same is if it's only x inside my absolute value. Then it would be the same. So does that make sense? Let's see, who did I just let in? Orion. Okay, so the only time it'll be the same is if it's only x on the inside. So here we go on the next one. So how many numbers have a distance of negative 8? Well, I can always tell you a distance of negative 8, right? So my answer is, there's no answer. There's none because I can't have a distance of negative 8. None. Not have a negative answer. Okay? So there is no answer. Yeah, good. Okay, and then the last one, and I have to get the absolute value by itself first. So the first thing I'm going to do is subtract 9. And I get the absolute value of 5 minus x equals 7. Is that right? 7? Yeah. So now the inside of my absolute value can have a distance of 7 or negative 7. So I can set up my equation to be 5 minus x equals 7 or 5 minus x equals negative 7. Okay, so subtract 5. Subtract 5. I'm going to run out of room. Negative x equals 2 and x equals negative 12. Sorry, negative x equals negative 12. So that means x can either equal negative 2 or positive 12. Because if negative 2 equals negative x equals positive 2, then positive x will equal negative 2, right? Divide by negative 1. So there's my answer for this one. Okay, so now you guys are going to try it. All right, so this is your turn to try. I think there's 4 problems here. So I'm going to give you... So, right, the first one is just x equals 10 or negative 10. Okay, so the second one, I'm going to subtract 2, and I get 7. Absolute value of q equals 7. Divide by 7. So absolute value of q equals 1, so which means q is going to equal 1 or negative 1. Since those are the two numbers that have a distance from 1 on the number line. Remember I said you got to get the absolute value by itself before you solve for it. So there we go. On this third one, absolute value is already by itself, so it can be 4 or negative 4. So 2x minus 3 equals 4, or 2x minus 3 equals negative 4. Add 3. Add 3. So I've got, let's see, 2x equals 7, and 2x equals negative 1. Divide by 2. X is going to equal 7 halves or negative 1 half. Okay, there's the answers there. And the last one, I've got to get the absolute value by itself. Wow, I can't believe I did that. I can believe I did that. So I have the absolute value of 2y equals 18. So 2y is going to equal 18, or 2y is going to equal negative 18. Divide by 2, so y equals 9 or negative 9. Okay, awesome job, everybody. There we go. So now we're moving on to the second set here. We're done with equal signs. Not too bad, right? If it's back for a second. So here, I took my answer, or my distance, right? Here was my distance. Let's do this one. Here was my distance. My distance was 4 here. And I took one positive and one negative. Great, because it was a number. Well, on these ones, but now we're going to move on to, oh, sorry, we are not moving on yet. Sorry. We have the double absolute values now. So if it's a double absolute value, I have to pick one of them to be positive and one of them to be negative. One of them to be I said that wrong. I'm going to pick one of the two absolute values and make it both positive and negative. So I'm going to choose one of these, and I think I'll choose the second one. No particular reason, just because it's the second one. That's it. That's the only reason. And make one of them positive and one of them negative. Well, how do I do that? I write it this way. So I have 3x plus 2 equals the positive of that, x minus 6. And 3x, let me move this whole thing over a little bit so I make sure I have enough room for everything. Sorry, guys. So I have 3x plus 2 equaling x minus 6, and 3x plus 2 equaling minus x minus 6. So I'm going to take the positive of it, which is just what it is, x plus 6, and I'm going to take the negative of what it is, where I'd have to distribute the negative through. Okay, so a little weird, I know, but one of them has to be a positive distance, right? One's the positive distance from 0, and one is I don't want to say distance, the positive number, that's the distance from 0, and one's the negative number, that's the distance from 0. So I have to have one side that's positive and one side that's negative, and I choose the same one. So then I'm just going to solve, So subtract x, add 2. So I get 2x equals negative 4, divide by 2, and x equals negative 2. And this one, so this would becomes a negative x, and this is a positive 6, right? So I'm going to add 6 this time. And again, I'm still subtracting 2. So I get 4x equals 4, divide by 4, and x equals 1. Okay? So my answer would be negative 2 and 1 on this one. Okay, so if I did this on this number 2, try and write smaller. It doesn't matter which one I make the positive or negative. So on this one, I think I'll do it on the first one so you can see that it doesn't matter. I'll get the same answer no matter what. So I'm going to make this my positive and negative 1. So I'll have 3x minus 1 equals 2x minus 4. And then I'll have, I'm going to write up here because I need the extra room, negative 3x minus 1 equals 2x plus 4, which would be negative 3x plus 1 equals 2x plus 4. So solve for x, subtract 2x, add 1. So I get x equals negative 3. And then on this one, I'm going to subtract 2x. And I'm going to subtract 1. And I've got negative 5x equals 3, divide by negative 5. X equals, negative 5, negative 3 over 5. So I've got two separate answers there. Okay, so I'm going to give you less time, to do these next two problems, but I'd like you to have your answer. Okay, so for A, if I did x minus 7 equals 2x plus 1, and x minus 7 equals the negative of this, 2x plus 1, becomes negative 2x minus 1. So subtract x from both sides, subtract 1 from both sides, and I get negative 8 equals x. And then add 2x, add 7, 3x equals 6, and x equals 2. And then the last one, and I think everybody got the first one right. That was great. The second one says, what does the second one say? X plus 4 equals x minus 3, or x plus 4 equals negative x minus 3. So that's x plus 4 equals negative x plus 3. So on the first one, if I subtract x and subtract 4, I get 0 equals negative 7, or no solution. Okay, And then the second one, thank you guys for continuing on and doing the second half of this question, because the first half is no solution, but there is another half of this question that does not necessarily mean that it's no solution. So good job. So add, oh, that's not an x, that's an x. Add x, subtract 4. So I get 2x equals negative 1. Divide by 2, x equals negative 1/2. I'm not sure I understand what your how do I know? Oh, on the original problem, how do I know when to make it a negative? Is that what you're asking? I always just choose the second one, just because then it's then it just becomes natural to make one positive and the second one negative. I could have chose the first one to do the same thing with. It doesn't matter, but I always just for routine for me, because sometimes that helps me if I do a routine, is I always take the second one and I make the one positive for one of them and then one negative for one of them. Does that help answer your question? Okay, awesome. Okay. So now we're going to go on to the inequalities. Okay, so here we go. So it says solve and graph. Great. Okay, we're going to solve and graph. Lovely. So it says, I'm not sure if what you mean by can we look at when before. Oh, look at, are you talking about the problem before this one? Okay. Did I do something wrong? It's entirely possible. Let's see, negative 2x minus 1. Nope. Okay. Oh, sorry. Okay, great. Can I go on now? JJ, are you good too? Okay, so remember our definitions. So this is where we need to have our definitions. And it says, I guess I'm going to let me come over here and write them. And it says, if I have, yeah, I'll write them over here. If I have the absolute value of x is less than p, that means I'm going to solve negative p is less than x is less than p. Okay, if I have the absolute value, and that's capital X, is greater than p, then I'm going to solve x is less than negative p, or p is less than x. So I have two separate equations to solve for no matter what. Okay, so this is that was in the definitions that we wrote down for inequalities. And it doesn't matter if it's less than or equal to, they're the same roles. Just when I graph it, it's an open dot or a solid dot. So if I look at, make it a little smaller, look at number one. Number one is a greater than sign, which means I'm going to use these rules. Okay? So it means I'm going to have my two equations. One of them is going to be 3y minus 4 is less than the negative of that, minus a minus 8. Okay? And then, or p negative 8 is less than 3y minus 4. Okay? So once I get done solving these, we need to actually look at the answers, but let's solve them first. So minus a minus 8 becomes positive. So add 4. Great, I can do that to both of those. And I get 3y is less than 12. Or, let's see, negative 4 is less than 3y. Is that correct? Awesome. So divide by 3. And y is less than 4. And then also, let's see, negative 4/3 is less than y. And that looks really bad. And that looks even worse. Negative 4/3. Okay. So because this is an inequality, why is it positive 8? Because it's the rule says minus p here. If you look at it, it says minus p. And p happens to be a negative 8. So minus a negative 8 becomes positive. Is that okay? Oh, okay. So now remember, my distance cannot be negative. So I need to look at my graph and see what my answer really is. So if I, oops, highlighter again. If I look at my graph here, and I've got, let's see, that's 1 1/3, right? So 4, 2, 0, negative 2, negative 4. Okay, so y is less than 4, so I have a circle on 4. It can't be 4, but it's less than 4. And y is greater than negative 1 1/3. So somewhere in here. Oh, that's too far. It needs to be on the other side of negative. Oh, the other side of negative 1. Okay, so the other side of negative 1 would be here. And then it's all my answers in here. Except, can it be, my question to you is, can it be these answers in here? Well, it can't be, because that's a negative. That gives my x, nope, sorry, I'm thinking wrong. Scratch that last thought. All my answers are between 4 and negative 4/3. That will make it greater than negative 8. And why it can do this is because it is greater than negative 8. There are some values that it can't be, like negative 8 to 0, but there are from 0 on up. So some of these values in here will make it greater than negative 8. So some of my answers would be a positive, in the positive realm. So that's where that would be at. Okay. Interesting. Okay, so if I go to the next one, oh, I can't see my rules and write at the same time. Okay, before I do my absolute value, the absolute value has to be by itself. So in this case, I need to subtract 7 from it. So I'm going to get the absolute value of 4x minus 5 is less than or equal to 19. Okay, so now this is a less than one. So I'm going to follow this rule right here because it's less than. I didn't change the direction of my sign or anything. So it should be negative p, which is negative 19, negative 19 is less than or equal to 4x minus 5, which is less than or equal to positive p, which is 19. Okay? Like so. Does the left side of zeros? Yes, sorry, honey. The left side of 0 does still count because I was thinking that was the distance and it wasn't. I was thinking wrong. This is not my distance. This, let me highlight again. This part over here the left side of 0 that I highlighted is not the distance. It's what y equals. So any of those can be y. So it can be that side. Sorry. That was my fault. Solve and graph. Yeah, it says solve and graph right here. Okay. How you're not supposed to graph on you can't graph on the in the chat box. I know that. So you'll just put in your answers, the inequality answers. Or you can put it in, actually it's easier in the chat box to do the interval notation because then you don't have to worry about the or equal to. Yeah. Okay, so then I'm going to add 5 to both sides. And I get negative 14. (24) divide by 4. Negative 7/2 is less than or equal to x, which is less than or equal to 6. So if I graph this, I'm going to slide over now for a minute, you guys, so I can kind of graph this. It's going to be a really rough sketch because I can't get well, if I do it really small, I can. 8. Ooh, let's do by 3s. 9, 6, 3, 0, negative 3. And that's negative 3.5, so negative 6, that should be enough. So on 6, I have a solid dot, and on negative 3.5, I have a solid dot, and x is greater than that and less than 6, so it's in between here. So if I had to put this in the chat box, I would just put negative 7/2 and 6 and just use interval notation because then you're not graphing it and you don't have to write the or equal to in there. So it's just easier to type it in as interval notation. And I believe once you guys do your checkpoint, it's interval notation also. So, okay, so go ahead and do these. Oops. Okay, guys, so let's go ahead and do these, I guess. So I'm going to subtract 12. And then I get negative absolute value of x minus 5 is less than or equal to negative 3. And because it's a negative, I have to divide by that negative 1, right? So I'm going to divide by negative 1. I get absolute value of x minus 5. And because I divided by negative 1, it changes my sign there, and I get 3. So now this is a greater than sign. So if it's greater than, that means I'm going to use this one right here, right? And I'm just going to put it into this just like what it says. My p is going to be 3 and my x is x minus 5. So I'm going to write two different equations. So I've got x minus 5 is less than negative p, and or p, which is 3, is less than x minus 5. Add 3, add 3, add 5. I am so sorry. Where did the 3 come from? Because I can't write. This should be 5. Let's try that again. 5. Add 5, add 5. Add 5. So I'm adding 5. Woo. And x is less than 2, or 8 is less than x. So if I was to graph that, I'd have 0, 2, 4, 6, 8, 10. Open on 8, open on 2. X is less than 2, and X is greater than 8. There you go. I think in your homework or on the checkpoint, they want it in interval notation. So you would have to write negative infinity to 2 joined with 8 to infinity. Okay? And then B, I have to get the absolute value by itself again. So subtract 30. And I get negative 4. Absolute value of 8 plus A plus 2 is greater than negative 18. Oh, wow. No wonder. Okay. Sorry, I did the problem wrong on my paper. I was like, why does the sign flip? I'm not sure. Flip when? Which time are we talking? Like when I divide or multiply by a negative number, then it flips? Or because I divided by a negative 1, right? On this one, I divided by a negative 1, so the sign flipped here. Or when I put it into the rule. I just actually put it into the rule like they told me to. I just used the rule. I followed what the rule said. So it depends on which time you're talking about when it flipped. Yeah, because this is what the rule says. And every time I've ever learned it or looked it up, this is what the rule says. So the rule just says if this is, oh, as I draw through that, I'm so sorry. If this is what my original equation is, this is how I solve it. And this is, with a negative p, it always will flip. And then this one, the second one, they just wrote backwards, if you can see that. If I would have put the x and the p in the right place, the same place. If you look at this one, my original equation was a less than or equal to, right? But once I got the absolute value by itself, and it was just the absolute value of something equals something, that's the sign that I'm going to use, because that's what the rules look like. It says the absolute value of x is less than p or greater than p. So I need to get the absolute value by itself before I decide which rule to pick. So my original equation here is not the same sign as here because I divided by a negative number. Okay. All right, so I guess I'm going to divide by negative 4. And I divided by a negative number, so I'm flipping it, and this is going to be 9 halves. Wow, okay. So then I have, according to my rule, this is which one is this one? The first one, the less than p. So I say negative 9 halves is less than a plus 2, which is less than 9 halves. So I'm going to make this bigger now. Okay, so I'm going to subtract 2 from all sides. So I'm going to subtract 4 halves and subtract 4 halves. Does anyone need to know why I did 4 halves instead of 2? Oh, Kim, sorry. Oh, yes, I can. Sorry. I will read those out loud. So she said, can you read out loud people's questions when they ask? Because I feel like it's something I might be confused about too. And yes, I can. I'm sorry. I will start doing that. Yeah. Okay. So, Okay, so we've got negative 13 halves is less than A is less than 5 halves. So 2.5. So 3. And that's to negative. So I don't want to go, oh, 3. Yeah, we can do that. 0, negative 3, negative 6, negative 9. So this is negative, this is 2.5. So it should be almost 3. And this is negative 6.5. So it should just be past negative 6. And A is greater than that and less than 5 halves, so it's right in between there. Okay. All right, there we go.